Hello and welcome back to our lecture series on Y parameter. So this is the second example we'll be doing under the topic Y parameter. So if you missed the previous part, kindly check the playlist on two-port network so you find all of the videos that has to do with two-port network. Alright, so now let's go ahead and look at this example too. So this is a typical example that you come across under two-port network, especially with Y parameter. Exactly. So it says find the short circuit parameter for the network below. Okay, so now look at it. If you look at this question, you can see that you might look at it that they didn't even indicate V, they didn't even show you the current direction and everything. We looked at something like this in Z parameter, where they'll just give you a circuit, they won't show direction, they won't show you V. Exactly. So that simply means they expect you to have how the diagram look like, or where the current direction will be, and where the V1 and V2 will be. Exactly. So don't let that to confuse you, or don't think that the question is not complete or correct. Exactly. So now let's do this. Okay, so in solving this question now, you can now go ahead and introduce the V1 and the V2. Exactly. So that means this will be our V1, this will be our V2, this will be positive, negative, and the direction of current will be like this for I1, and here will be our I2 in this direction. Exactly. Okay, so this place should be 40 ohms. Okay, so what I would need to do now is just to redraw the circuit, and then so that I can close this part here and form a closed part. So because I would like to use mesh analysis like I've been doing. Okay, so I've gone ahead to draw the circuit. Now, there's something I didn't mention at the beginning is that of this question, there are actually two ways. There might be more than that, that you can use to solve this question. But let's just go through this first, and then I'll be showing you the other way of solving this question. Exactly. All right. So now let's pick our direction. So this will be our I2, and this will be our I1. Okay. So based on this, this will be my. So let's do this. Will go in this direction. So this will be my I1. And then this would be in this direction for I2. Okay, so this will be my mesh 1, which is the input side, and this will be my mesh 2, which is or you call it the output side. Now you see this third mesh, you can pick any direction, either a clockwise or anti-clockwise. Exactly. So but for this now, I'll just go ahead and pick a clockwise direction like this, and then so this will be my I3. All right, so now let me go ahead and add polarities to all the resistor based on the direction of current. So this will be plus, minus, plus, minus. So due to I2, this will be plus, okay, sorry. This will be plus, minus, plus, minus, okay. So due to I3 now, this will be plus, minus, then plus, minus, okay. So like I said, I'm applying the Kirchhoff voltage law here. That's mesh analysis to do this. All right, so now let me simplify them one after the other. So if I should apply KVL to mesh 1, so starting from the V1, so I'm going to be having V1, and then when I come over to this 10 ohm resistor, due to current I1, it's from positive to negative, so that will give me minus 10 I1. Also from negative to positive due to current I3, so that will be plus 10 I3. So let's move over to the 40 ohms resistor. So from positive here to negative due to I1, so that would be minus 40 I1. Also from positive to negative due to current I2, that would be minus 40 I2. And that is the end of that particular part of that mesh, so equals to 0. So let's tidy this up. So we are having V1, so we are having minus 10 and minus 40 I1 here. So that will be minus 50 I1. Then let's see, are we having I2? Okay, minus 40 I2. So that will be minus 40 I2. What about I3? Plus 10 I3 equals to 0. So what I want to do is let me move all of them to the other side apart from v1. So I'll be having v1 equals to 50i1 plus 40i2 minus 10i3. Exactly. So this will be my equation 1. So take note of that. That is our first equation. So if you also decide to do the same thing so that's to apply KVL to mesh 2. Apply KVL to mesh 2. Okay. So if we should do that now in anticlockwise direction, so let's start from V2. We are going to be having V2. That's because from negative to positive. Then when we come here, which is the 5 ohm resistor, so from positive to negative, that will be minus 5i2, also minus 5i3. Then for the 40 ohms, so it will be from positive to negative, so that will be minus 40i2 and also minus 40i1 equals to 0. Okay, so if you should tidy that up, we are going to be having V2, are we having V1? Okay, yes, minus 40i1. Okay, what about I2? We are having minus 5 and minus 40, so that will be minus 45i2 and then minus 5i3 equals to 0. Okay, so now let me move every other thing to the other side of the equals to side apart from V2. So that means V2 will be equals to 40i1 minus 45i2, sorry, to be plus 45i2, then plus 5i3. Okay, so this will be our equation 3. So let me put that. So I just want to make sure that as we are getting the equation, we can be seeing the circuit. Exactly. So this is our, okay, so this is our equation 2, not equation 3. So this is our equation 2. Okay, so let me just create space for our equation 3. Let's just scroll down. Okay, so we've done that of mesh 1, mesh 2. So now let's do for mesh 3. So this is mesh 3. Let me indicate it. This is for mesh 3. Okay, so we can just start from anywhere. So let's just start from the 10 ohm resistor. So if the current should flow in this direction, that's clockwise. Yeah. So if it should flow in that clockwise direction from positive to negative, so that will be minus 10i3. Also from negative to positive due to I1, so that would be plus 10i1. So then for the 20 ohm resistor, so this will be plus and minus, so it will be minus 20i3. So the next one is the 5 ohm resistor from positive to negative, so that will be minus 5i3, and also from positive to negative due to I2, so that will be minus 5i2 equals to 0. Okay, so now let's tidy this up. So this is the only I1 we are having here, so that will be 10i1. What about I2? This is the only I2 minus 5i2. So I3, this is I3, this is I3, I3. So minus 10, minus 20, and minus 5. So that's minus 35i3 equals to 0. Exactly. So let's still go ahead and put this as our equation 3. Now, if you look at our equation 1, which is this, and equation 2, and our equation 3, or let's just look at equation 1 and equation 2, you can see that this I3 that we are having here is making it look different from the regular Z parameter equation. Exactly, because the regular Z parameter just have our V1 is equals to Z11 I1 plus Z12 I2. But now we are having I3. So what can we do to get rid of it? So for us to get rid of it, we have to get the value of I3. Exactly. And so to do that from your equation 3, you're going to make I3 the subject formula. So from equation 3, so make I3 the subject formula. So if you should do that, we are going to be having I3 will be equals to 10I1 minus 5I2 divided by 35. Exactly. So let's just put this as our equation 4. So the next thing we are going to do is we are going to substitute the value of I3 into equation 1 and equation 2. Okay, so let's write it. So substitute the value of I3 into equation 1 and 2. Okay, so in doing that now, so we say from equation 1, so what's that, our equation 1 again? So let me just copy that so that we can just see it. So from our equation 1, which is this. So now we are going to substitute the value of I3 in place of this I3 here. So that means we are going to be having our V1 will then be 50I1 plus 40I2 minus 10. So then our I3, so this is our I3 here, 10I1 minus 5I2 all over 35. Exactly. So that means we'll be having 50I1 plus 40I2 minus 100I1 over 35. So I'm using this minus 10 to open up the brackets. Then plus, so because this is minus 10 and minus 5, so that'll be plus 50I2 over 35. Okay, so if you should continue, so that means our V1 will be 50I1 plus 40I2. So 100 divided by 35, so that would give us 2.86. So that will be minus 2.86I1. Then 50 divided by 35. So if you type that in your calculator, you'll be getting approximately, so that plus 1.43I2. Are we good? So that means our V1 now will be, so you can see that's 50I1, then we have minus 2.86I1. So if you do that, you're going to be getting 47.14I1. Also, we're having 40I2 plus 1.43I2. So if you should add that up, we'll be getting plus 41.43I2. So now this is our new equation. So you can see I have having an equation that is just I1 and I2. So that will be our equation 5. So this is our equation 5. So what we've done to equation 1 now, let's go and do it for equation 2. So now from equation 2, so if you are finding value in this, please give the video a thumbs up, give it that like button, and so from equation 2, let's go and recollect what equation 2 is. Okay, so this is our equation 2. Let me copy this also. So that we can see it. So from equation 2, so now let's replace the value of I3 in this equation 2. So that means we are having our V2 will be equals to 40I1 plus 45I2 plus 5. Then, so our I3, 10I1 minus 5I2 10i1 minus 5i2 over 35. Okay, so let's do this. So that means our V2 will be equals to 40i1 plus 45i2 plus, so that will be 50i1 divided by 35. 5 multiplied by minus 5, so that will be minus 25i2 over 35. Okay, so that means our V2 now will be equals to 40i1 plus 45i2. So 50 divided by 35, so that will be plus 1.43i1. Then 25 divided by 35, so that will give us 0.71. So that will be minus 0.71i2. Okay. So with this now, that means our V2 will now be equals to, so this is I1, this is I1. So that's 40 plus 1.43i1. So that will give us 41.43 because they are both having I1. So also for I2, we are having I2 here, I2, just like bringing the like terms together. So 45 minus 0.71, and that will give us, so this is I1. That will give us plus 44.43 I2. So we now have another equation. So this should be our, so this will be our equation 6. So always note your equations like this, it helps a lot. So from our equation 5 and 6, we already have our z parameter. So from our equation 5 and 6, exactly, so we have our z parameter, which is times our z. So let's just put it in matrix form. So that's our z11, z12, and z21, z22. Okay, so with our equation, so this is it. So that means we are having our z11 is 47.14, our z12 is 41.43. Okay, so this will be 47.14, and then the other one will be 41.43. Then our z21, this is our z22, so that's 41.43 and then 44.43. So that's not our answer here, because the answer did not, the question did not tell us to get the z parameter. But assuming we are asked to calculate for the z parameter, exactly, then we've gotten the answer already. But no. So what we'll now do is to convert the z parameter into y parameter. So in doing that, again, so one thing that we are going to need is the determinant of this z matrix. So let's calculate that first. So that means our z will be equals to, so this multiplied by this subtracted by the multiplication of this. Okay, so that will be 47.14 times 44.43 minus 41.43 times 41.43. So if you type this in your calculator and you do it correctly, you are going to be getting 368.56. Okay, 368.56. So I haven't gotten that. If you remember from the previous example, the formula to convert z parameter to y parameter, so let me get that. So our y11 is z22 over the determinant of z. So that means, so our z22, this is our z22, 44.43. So that's equals to 44 point what? 43. So it's actually 44.23. So 44.23, not 43. So let me quickly correct those. So 44.23. 23. Okay, so take note of that. So 44.23 divided by 368.56. Okay, so if you should do this, we are going to get in 0.12 exactly. So we've gotten our y11. So for y12, to convert it from to get our y12 from our z parameter, so that is minus z12 over the determinant of z. Okay, so that will be minus. So what's z12? So z12 is 41.43. Okay, so that's minus 41.43 divided by 368.56. So if you do that, let's type this in our calculator, then we'll be getting minus 0.11. Okay, so we are gradually rounding up. So y21 now. So for y21, that will be minus z21 over the determinant of z. So and that will be minus, so what's our z21? 41.43. So that will be minus 41.43 divided by 368.56, and that will also give us minus 0.11. So this is 0, this is also 0. Okay, so then our y22, to get our y22, it is z11 over determinant of z. So our z11 is 47.14. So 47.14 divided by 368.56. Okay, so if you type this in your calculator, you should be getting 0.13. So if you look closely now, we've been able to get, so let me go ahead and add the units. Don't forget, the unit is very important. So like I said, you can try to just add S as the Siemens or per ohms, or you can just use this exactly, whichever of the three, either of the three will be fine. So if you look at what we have here, we've been able to get the y parameter exactly, and this is it. So these are the y parameters for that particular question. So this is how you go ahead to solve a question like this. However, I promised at the beginning that I'm going to be showing you another method that you can use to solve this question. If you don't want to go through this route. So before I just give you a clue of what that second method is, your answer might be a little different from mine because of the values that we are getting. You can see we are not getting a whole number. We are getting numbers in decimal. So in the process of maybe you are using 3 decimal places, 4 decimal places, or in the process of your approximation, you might get a slight different from answer from this exactly. But it will be very close. Probably maybe you might get 0.13, where I'm getting 0.12 exactly. But in some of these cases, you get the same answer. So this is how you go ahead to solve this kind of question. This is a typical question under two-port network, especially Y parameters. You can see this example is longer than all other examples that we've been looking at. Exactly. All right. So if you find value in it, please give it a thumbs up. Like I said, I'm going to be showing you another way to go about this. That is, if you decide not to use mesh analysis to simplify this circuit, you can decide to use the delta star transformation, and that is what I want to show you. So just to make sure this video is not too long, I'll be showing you that in the next video exactly. So if you have any question with respect to this solution, just let me know in the comment section. If you are confused in anything, just let me know in the comment also. But I will encourage you to try to watch the video over again, because I try as much as possible to simplify this solution for you. So thank you very much, guys, and then please subscribe if you are yet to. Try to show some love. These things takes a lot of work. So make sure you subscribe to the channel, like, share, subscribe, and then I'll see you all in the next example where I'm going to be showing you an alternative way of solving the same question. All right, thank you.